In this video, I'm hoping to give you some tips and do some examples that might help you pass the objective in your focus area on linear, quadratic, and exponential functions review. This one I'm going to focus on quadratic functions. So where I'm going to start is I'm going to start with just key characteristics of parabolas. So if you see on these notes, I've got f of x equals ax squared plus bx plus c. This is standard form of a quadratic. These coefficients here, a, b, and c, they reveal certain attributes or characteristics of the parabola, which is the graph of a quadratic function. Now, most of this you learned in Algebra 1. Most, if not all. So on this table, the first thing we're looking at is if a is greater than 0. What does that mean? What does it mean to be greater than 0? Basically, that just means that these numbers are positive. If a, this leading coefficient here, the number that's right next to the x squared, if that's positive, then I know the following. The parabola is going to open upward every single time. Doesn't matter if it's 2, 10, 15, doesn't matter. As long as it's positive, I'm going to have a parabola that opens up. I could have something that looks like this, or I could have something that looks like that, or lots of different parabolas. But I do know if a is positive, it opens upward. Likewise, if a is less than 0 or negative, I know this. The parabola opens downward. So I could have something like this, something like this, just as long as it opens down. So the leading coefficient, the number next to x squared, tells us if it opens up or down. Now, this next notation with these bars, remember these bars mean absolute value. Absolute value is distance from 0. So essentially what this is saying is when a, that number, is greater than 1 unit away from 0, then what I'm about to show you is going to be true. Now let me just kind of make it a little bit more in terms that you might understand a little bit better. Let's do this. Positive numbers bigger than 0. Or I'm sorry, bigger than 1. So for example, 2, 3, anything like that. If I've got a number, if a, that number that's next to x squared, if it's a positive number bigger than 1, it's going to be narrower. Now what I mean by that is, let's say that's x squared. Then something like this would be narrower. Looks like it's pinched in. So actually I could replicate that exact picture over here. So x squared looks something like this. Okay, and if the leading coefficient was a number bigger than 1 like that, say for example might be something like 4x squared. And this is just x squared. That could happen. Now this next one, numbers that are between 0 and 1. What type of numbers would we see there? Well, in other words, those are fractions. Fractions less than 1. So for example, I could have 1/2 x squared, something like that. If it's a fraction, then the parabola will be wider than just x squared. So if I put just x squared on here again, then if the leading coefficient was a fraction, I might see something like the red one here. And let's just say, for example, this is 1/3 x squared. And then last, c. So we're not talking about a anymore. And to remind us what c is talking about, c is the constant, the number that does not have x with it. That number, every single time, will always be the y-intercept, meaning it's going to cross the y-axis at that number. You can also find the y-intercept, remember, whenever you plug in 0 for the function. Because remember, a y-intercept, where something touches the y-axis, is whenever x is 0. So for example, if I plotted a parabola that looked like this, the y-intercept is 6, at least that was my intention with that, then I would know that c would have to equal 6. So I could have x squared plus probably something else plus 6. Now there's a reason why I know that there's probably this middle term here, and I won't get into that right now. That's not important. What's important is that you just know that this last number here, the number that does not have an x, matches up with the y-intercept. So let's take those concepts and answer some questions. So these questions are like what you might see on your content assessment. Which of the following functions will create the graph to the right? Now there's a couple ways that I could look at this. I can go from my options to the graph, or go from the graph to my options. I'm going to go from the graph first. So here's what I know. My y-intercept is 4, and it opens downward. So that tells me my y-intercept, I'm going to have +4 at the end, and that if it opens downward, I'm going to have a negative next to the x squared. Well, look at that. I actually just wrote that function. So that's the one that matches. It's not this one, because that's a y-intercept of -4, and my leading coefficient is positive, which should mean that the parabola opens upward. Neither one of those things is true, so it's got to be the first one. Let's look at the next example. Which best represents the graph of 3x squared minus 5? Okay. Looking at this, minus 5, that number, that means the y-intercept has to be -5. That rules out one option. Do you guys see which option that rules out? Hopefully you saw it rules out this one, because this has a y-intercept of +5. These have y-intercepts of -5. So then how to choose which one is which? Well, do you remember what I said about when this leading coefficient is greater than 1? What that's going to do to the graph? That's going to make the graph narrower or skinnier. So that makes me think it's going to be this one, because that graph is narrower or skinnier than this one right here to the left of it. Then this last one. What should be true about the graph of -2x squared plus 3? Doesn't matter where we start. Let's say I start with the -2 part. What does the negative tell me should be true? Well, we don't have to be too specific. All we could say is that it opens downward. So I've got something like that. What does the 2 tell me? So the negative tells me it opens downward. The 2 tells me that it's narrower than x squared. So then I could maybe do something like that. And then last, what does the +3 tell me? That's my y-intercept. Y-intercept equals 3. So if I just wanted to draw a general sketch, the y-intercept has to be at 3. and it opens downward, and it's kind of skinny. So you know what else I also know? Because my y-intercept is positive, it's above the x-axis. Let me do this. The y-intercept is above the x-axis. And the parabola opens downward. I know it also must cross the x-axis twice. I could have a parabola that opens downward and that had a y-intercept of -3 that would not cross the x-axis twice. But because it opens downward and at least some part of the parabola is above the y-axis, that makes it have to cross the x-axis twice. Okay? So some of the questions on your content assessment are just seeing if you understand these two things. Do you understand what the number in front of the x squared tells you? If it's positive, opens up, negative opens downward. Do you understand what this last number tells you, the one with no variable? That tells you where the y-intercept is. If you understand those two concepts, you can answer questions like what you see here on the content assessment. The next type of question you might see is talking about x-intercepts or factors or solutions and connecting those two things together. So I'm going to take you through a series of questions that'll help you make those connections. If I look at this graph, what do I know? I know that it opens upward. I know that my y-intercept looks like maybe it's -3. We'll just go with that. I know I've got two x-intercepts. I've got an x-intercept at 3 and -1. That's what I know. I'm sure I could say more, but those are just the key characteristics that we've been focusing on. It doesn't look like it's narrower or wider. I could put that it just looks normal. But that may not be helpful in the long run. But it doesn't hurt to put down more and end up not needing that information. So let's look at the next part. Solve the equation 0 equals x squared minus 2x minus 3. Okay. So you may not realize this, but there's a couple of things that I recognize about that equation and the graph. First of all, the y-intercept is -3. Look at the constant at the end, right there. It opens upward. Notice the leading coefficient, it's not negative, it's positive. And also it looks normal. So that leading coefficient isn't anything other than 1. It's not 2 or 1/2, it's just 1. So positive 1 there. So this x squared minus 2x minus 3 could very well possibly be the description of that graph. But what they're wanting us to do right now is to solve. So let's review. If I've got an equation like this, you should know by now that there's a couple of different ways that I can solve a quadratic. One of those ways is by factoring. Another way is by completing the square or by using the quadratic formula. I don't know about you, but if I look at a quadratic equation and I can factor it, that's the route I take, because if it can factor, especially if the leading coefficient is 1, like it is here, then it might be super easy to factor. So what am I looking for? I know if it factors, it will turn into something like this. Now I also know that because this is a -3, these signs have to be different. So I'm looking for what two numbers multiply to -3, but add to negative 2. Those two numbers are negative 3 and positive 1. Negative 3 and positive 1. So the 3 has to go here, the 1 goes here. And then do you remember what you do after you factor it to solve? It's pretty simple. If x plus 1 times x minus 3 equals 0, then that means either this equals 0 or this equals 0. So I just have to set up two equations, two little mini simple equations, and solve for x. X equals negative 1, x equals 3. So my solutions are negative 3. Oops, I'm sorry, not negative 3, positive 3. And negative 1. So then the next part is, what connections can you make with the graph above in the equation 0 equals x squared minus 2x minus 3? Well, we kind of already talked some about this. Negative 3 is the y-intercept. This tells me that it opens up. But what I'm trying to get you to see is that the solutions here, 3 and negative 1, where do you see those numbers here where I was looking at what was true about the graph? 3 and negative 1. Do you see those numbers anywhere? I hope so, because they're right here. The solutions of 3 and negative 1 are the exact same thing as x-intercepts. That's always true of quadratics, parabola, also of polynomials, something that you'll learn later on. If I solve a quadratic, that also tells me where it crosses the x-axis. So let's fill this in. X-intercepts and solutions are values of x that make the equation 0. So because remember, solutions, if I plug in 3 and negative 1, both of those in for x, that should make the equation equal 0. That's what a solution means. So it makes the equation 0 and where the graph crosses the x-axis. That's what an x-intercept means. Oh, now this is the part that I didn't connect though. Factors. So let's go back up to here where we solved. Factors are talking about these right here, when we factored the equation. X plus 1 and x minus 3. How are those connected to my solutions? Well, they're almost the same. It's just that they're opposites. Because when I had to solve here, like in this one, I had to subtract 1. So I've got positive 1, negative 1, opposites. Here I had to add 3 to solve for x. Negative 3, positive 3. So factors are connected to x-intercepts and solutions, but are the opposites of those two things, x-intercepts and solutions. So hopefully making some of these connections here will make these next questions make a little bit more sense. And these are examples like what's on your content assessment. So which of the following functions will generate the graph below? Okay, first, let's look at the graph. What do we know about the graph? Opens downward. Looks like it has a y-intercept of 5. And it has x-intercepts at negative 1 and 5. So remember, these numbers are connected to the solutions, but remember they're opposite of the factors. So let's look at the first one. For the first one, in order for this to open downward, I need to see a negative in front. There's no negative. This opens upward. so it can't be that one. So I don't even have to look at the factors. This one also opens up because there's no negative in front. So it means it's got to be one of these two. So how I figure it out, this one's got +5, -1. I guarantee you if you're going too fast and not paying attention, you would circle this one because you go, hey, look, +5, -1, +5, -1. Boom, that's it. But no, the factors have to be the opposite of the x-intercepts, because remember, this is what we solve to get my solutions and my x-intercepts. So if this were the equation, my x-intercepts would actually be -5 and +1, and that's wrong. So that leaves me with the third option, or the fourth option. But let's talk about why. Why is it the third or the fourth option? It's negative, so opens down. That's what we want. Then my factors are x -5 and x +1. Those are opposites of -1 and 5. So we're good. So it has to be this function. Make sure you're taking your time, because I guarantee you the part that's going to trip you up in a question like this is connecting the x-intercepts with the factors, and you're going to want to keep them the same, but they are opposites. Okay, if you're taking note, underline that, highlight that, put a sticker by it, whatever you want to do, tell it to a friend 5 gajillion million times. That is one of the most frequently missed concepts with quadratics, solutions, x-intercepts, factors. Mixing up the connection between those three things. So let's look at this one. The graph of y equals x squared plus bx plus 6 is shown below. Based on this graph, which value of b will satisfy the equation? 0 equals x squared plus bx plus 6. The plus 6, remember, that's the y-intercept. Now, where am I going to get this from? This is not really something that we've talked about yet. But let me just take you through the process that you need to go through. If I look at this graph, the x-intercepts are at 2 and 3. That means the solutions are 2 and 3. What does that mean the factors are? Remember, factors are opposites of x-intercepts and solutions. That means it's got to be x minus 2 and x minus 3, because these numbers need to be the numbers that when I plug it into x, make it equal 0. Okay, so you know what? I'm super close. Wanted to mix the words so and super. So super close to getting my answer. All I have to do is take what I have here and multiply it out. X times x, x squared. X times -3, -3x. -2 times x, -2x. -2 times -3, +6. So there's my plus 6. Just combine my like terms to -5x, and bingo, I've got my b. My b equals -5. Okay? So again, in a nutshell, what I did, if I want to find b, that middle term here, that's going to be connected to my x-intercepts, which did that first. Remembering that when I turn them into factors, it's the opposite sign. And then I just multiplied out and identified the right term. Let's look at this one. So based on the graph, which value of c, now we've got a different equation, and we're finding a different variable. This one is not near as complicated as the other. All you have to do, remember what C is? C is the y-intercept. Where's the y-intercept? It's at 5. So there's my C. Boom, done. I would say of all these examples that I did, the one that's probably the most difficult is going to be this example 5. If that one just blew your mind, I would suggest pausing, rewinding, listening to that solution a couple different times until it locks in. Remember, what I really want you to remember is that factors are opposites of solutions and x-intercepts. Okay? Hopefully this video helped you out. Thanks for watching it, and good luck on your content assessment.